So I'm Sam. I chair the Trilinos Framework DevSecOps team, whatever buzzword we're using year to year. This is going to be kind of a laundry list presentation of what we accomplished last year and what our, and probably more importantly, what our plans facing this current year are. Anywhere in here that I put FY, I probably mean CY because I did update the what we got done to be kind of on the HPSF cadence, which is closer to the end of the calendar year than fiscal year. So that did too for some reason. Okay, FY25 accomplishments. Deprecated package removal, I could say a lot about this. I have a slide dedicated to it later in the presentation, at least some of the highlights, but we removed all of our Epetra-based stack and some other, they weren't all strictly related to Epetra, but removed all deprecated packages as of the 17.0 release. We did kind of a funky multi-release candidate step release for this one so that we had mile markers for people to test compatibility if they so chose. But this is done. Everything's finished. Trilinos 17.0.0 is out as of early February. This was a this took probably a year of just mechanical work to try to keep people running as best as we could during the transition, and then multiple years of communication. So this was the culmination of a long effort to get some deprecated code out of Trilinos. We released all pieces of our gen config configuration management tool as open source, and then we immediately set them all to archived, never to be developed again. These weren't open sourced for development purposes. They were open sourced because it felt really odd to use a closed sourced configuration management set of Python tooling to manage the CI configurations for an open source code. The whole point is we want people to be able to reproduce pull requests, and that means people outside of Sandia. So to that end, we open sourced all that, and it's all available in our containers now. All of our compiler and MPI tool chains got upgraded this year. I did check this. It was every single one, some of them multiple times as we encountered issues. But the ability to do that was a great reflection on the new container-based CI system. We updated the Spack check. We currently check every single pull request to see that it doesn't break the basic Spack install Trilinos workflow. It's a bit of a smoke test, but we find it to be an important one. There's some code in our package.py that ensures Cocos and Trilinos version alignment, and that is probably the single largest thing that breaks people when we upgrade Cocos and we don't upgrade it in the Spack package. So we upgraded that to use the developed version of Spack because otherwise we didn't get the new package repository. This isn't strictly necessary anymore. We could just upgrade the package repository on its own because of some new work in Spack, but we still kind of want to make sure that it works on the head of develop. And then we advanced the minimum C++ standard from 17 to 20. This was part of our upgrade to Cocos 5, but we accommodated it in our own C++ default settings. What's up, Jim?
One clarification and one question.
Yeah.
That Spack check, that's non-blocking, right?
That is non-blocking, correct. It's informative only.
And then what is the relationship between gen config and the future path versus the current path?
Unknown, honestly. Yeah, you made a good point. I should have said, we said we're not going to develop it, so do we really want to use it? We didn't want to address changing over all the configuration management. I do not foresee us using that in the far future. I'm not sure where it lies to change it, since we haven't really had to muck with it too much as far as capability. It's still a lot of configuration options to manage, but that's not really a manager problem. That's a problem with how we address dealing with what we're going to test. So we decided that the path of least resistance here was to just open source the tool that we're not super happy with instead of going through a rewrite of the tool, especially in light of the fact that that tool's only been in existence for 3 or 4 years.
Yeah, it seems like it's fallen into being like a reasonable steady state solution.
Exactly, yep. We don't have a great reason. And long term, it might be nice to use Spack a little bit more because again, that's something that other people outside of as far as I know, non-existent other user base of this tool are familiar with managing configurations.
Yeah, that's a good point. You can let the Spack relationship to Trilinos evolve.
Exactly. Yep.
Other solution becomes more clear.
Precisely. Okay, that was kind of a light achievement slide because most of our achievements had to do with our CI/CD testing infrastructure. This is the Autotester 2 system that is the successor to the old system that was running inside of our Jenkins server that did a polling, reach out to GitLab or GitHub, start tests, report back. We've moved to a almost purely GitHub Actions-based approach. There's still some runner side code that does some approval checking, but everything has been converted. This was a multi-year effort. I'm extremely happy to say we've finished this. There's still improvements that can be made, but we're at least in the point where I think the capability from the old auto testing system has been surpassed. So the stuff that we want to continue to do to it is additional capability, not backfilling for lost capability. So here's some highlights from what we did this year to make it a little bit more usable. We added run artifacts to our GitHub Actions-based builds. I'm not going to go through each one of these, but the idea here is we want people to have the information they need to reproduce pull request builds. It's still not the most simple thing in the world. For example, if you don't have access to our image, you do have the Docker file, you can go build it yourself, but that induces a pretty big overhead to an external customer wanting to reproduce a failed build, but they can do it where previously they couldn't. So it's still a better state than we used to have. We added the ability to inspect by label for developers that are familiar with our legacy system. This is currently not working, but I wanted to put it on here anyway because we do anticipate getting it working again very soon. This is the ability to differentiate between I approve this code to be merged into Trilinos. Spiritually, it's a good change, versus I approve it, it looks safe to test. We would like to be able to keep that distinction. If anybody saw the Hubcast presentation at the CI working group, they have something very similar. They use a comment bot, kind of like Dependabot. If anybody's interacted with that, you can tell the bot to do things in a comment. We use a label. We added an automatic rerun tool that ties into that same label-based system, where if a check has failed and then the label got added, we go ahead and rerun it to see if that was why it failed. I don't think there's a way to trigger a GitHub action based on a label setting. I feel like we would have checked that, but it's been a while since we put that code in, so I don't want to claim it for certain. And even if we could, I think we might have said we don't want to be as we don't want to run for every single label that gets set. We don't fail CI builds if the C- submission fails. So this is being a little bit more selective in our automation code. We don't really care that much if we miss a C- build, as long as all the tests passed. It would be great if we got all of our C- results, but let's be honest, the server goes down sometimes. There's not really a good reason to halt development if things passed, so we added that as a usability improvement. We now log all of our Ccache statistics into the GitHub Actions log. We want to be able to check to see how effective our object caching is at being hit as we run through our CI builds. It's very effective for us, usually upwards of 90%, so it's important for us to be able to go back check to say, hey, something's not right. The CUDA builds are taking a long time, and the hit rate's only 20%. Oh, it's because the cache got set to read-only for some reason for the last couple months. Things like that have happened. So the ability to go check this in the actions logs is really helpful. We added instructions on how to build our container images that we use in CI to our open Dockerfile repository. That's pretty self-explanatory. Added GPU architecture tags to our GitHub Actions runners. Previously, we only had one GPU available. We added more, so we want to be able to differentiate and not land on an improper architecture GPU and the tests start behaving differently. And then last, we upgraded Spack in our Dev CI containers to be about version 1.0. I think we're a little bit past that, but this is big for the compilers as dependencies work that went in last year. This is a big upgrade, and it went surprisingly smoothly, so that was good. So this is a laundry list of our current CI configurations. I'm not going to go through them all in detail. The thing I'll highlight is that descriptor in the far left column. That's kind of the abstract reason for having each build. I try to keep that simple. Like you'll see one's just called OpenMP. It's still a GCC OpenMPI build, but we turn on the OpenMP backend for Cocos host. I don't have a whole lot to say about this one other than there are other individual test coverage things for some of the builds. I didn't want to write them all out and make this even more of an eye chart, but you can see we try to cover static and shared builds, different build types, different Red Hat versions. The one thing I'll note is this rdebug thing. That is a CMake build type of release, but we turn on some runtime debug checking. Chris?
So the CUDA test, what GPU is that?
Right now we're testing on Ampere 100s. We have 2 of those per each testing machine. We have 3 of those machines. So I was a little nervous about getting good throughput on those because we came from quad voltas, and it has been reasonable. We were able to load them up. They have a bit more memory per GPU, so we've been able to get decent throughput.
Well, are there any plans to test
Not in CI, or resource constrained. But I'm glad you asked, because we previously had nightly tests. These are things that obviously aren't required to pass for every pull request. We don't. Usually, it's because we don't have the resources, whether that be time or hardware. A lot of these are very long-running builds, like Clang Address Sanitizer, or the tests that come after them. Code coverage is another good example. We used to have these for, well, most of these we used to have with our old configuration management tool. But with all of this tool chain transition, we lost all of our old build configurations, and we did that deliberately. We prioritized getting the CI working because, well, at least that way we know the code's going to work. But a lot of these are additional nice-to-haves. I think there is a typo in the column on the first build. I'm pretty sure we're doing debug for the bounds check build, and I knew that, and I don't know why I wrote release there. I will say these Cocos develop builds that are right under the bounds check, these are integrations of our snapshotted packages, Cocos and Cocos, well, two of our snapshotted packages, Cocos and Cocos kernels. That's probably going to go a bit different direction. I think that Christian and I talked a while back. We're probably going to do an automatic pull request that gets opened every night, and then it just runs all of the pull request tests for the Cocos integration. And that's kind of the ideal case, because Nathan Ellingwood's been asking for a long time, can I get an Intel, can I get a CUDA, they want to see the full gamut of all the testing. Jim?
To get to Jonathan's question, were you going to mention the NSA integration effort on
I was.
Never mind.
I can now. I'll highlight these bottom two. So these bottom two are, we have access to the hardware, but we either don't have enough of it. In the case of the H100s, we only have one quad H100 machine. We're not really confident about getting good throughput on that for pull request testing. But that's plenty to do a nightly build. And then for the MI300A build, that corresponds to the ATS4 El Capitan supercomputer. We have a machine at Sandia that can do it, but it's not on this same kind of open network that we can push results out to the public. But the University of Oregon does have a machine called Frankenstein that has some MI300A nodes. And there is some work underway to get that put in, and those results would be available on the open side because they're running on open hardware.
You may be able to do a non-blocking PR build.
It's possible. It depends on what the throughput looks like. So we don't know which one of those we're going to target. It's going to be one of the two, almost certainly, unless we magically procure another MI300A node specifically for us on our open network. I find that very unlikely. But that's the point for these two. But then other things you can see, like these middle three, are more like code quality checks. So that's what's upcoming this year.
Sam,
Yes.
why do you choose static on the ATS, on the CUDA, the last two?
I cannot answer that for the bottom one, but for the one above that, it's because I was told that we want to only use static for GPU builds generally. That's not a me decision, absolutely, though. And I will, of all the people in this room, I think I'd defer to you more than anybody if we want to do shared either of those. What? Okay, but for non-RDC, we could do shared. I see whichever one is the more common and applicable to the users, and again, I'll defer to this community on that.
Just as a buyer beware, I ran into an issue with if you are testing with another code that uses Cocos and things were built statically, there's a linter bug that will cause double structs and other fun things. So
I believe it.
be wary of static builds.
Shared when possible is my preference as somebody that does software stack maintenance, but
I mean,
yeah.
The static and RDC thing is critical to Gemma, to Empire, to Thermal Spirits and Sierra. That's why, I mean, I don't know where to do, so I talked with Kurt and Chris about this at one point. It's how can we test RDC better?
Yeah.
But I definitely, if you need a throughput testing, you can totally do shared with Browne.
That's a good point. So if that, and I would say if that allows us to get it into PR, I think we should go that direction. Because in my opinion, these are nice to haves, but realistically, it's not even same order of magnitude usefulness to catch it at pull request time versus oh, it's already gone in, now we have to look at it nightly and go redo it. Chris?
So the other thing that Christian brought up at one point is just cross-compile for MI300A.
It's very, very possible. It's more difficult. It's more infrastructure. it's something that I've been preaching on other projects inside Sandia just for regular NVIDIA builds, right? Because we have good node hardware to do these builds on. It's running the tests. And I'd love to do that long term on this, because that would also probably allow us to put the H100 build to a PR build. 4 H100s is pretty good for testing throughput.
I have other comments, but maybe we just talk offline.
Yeah, I'm happy to do that. Okay. I've been maintaining this on my own computer for a while. I don't share it all that often in every venue, but I wanted to do it at this. That green does not show up well at all on this. I hope people can kind of vaguely see where the cell lines are missing, and you can hopefully assume that those are the green bars. This is a roadmap of our compiler support. This is intended to be a living document. I change it regularly. The real takeaway here is, I think for the first time in a couple years, I can say Trilinos is on fairly modern compilers and has a good breadth of support. That's not going to continue if we don't continually maintain that. So I'll check in next year and see if we can still say that, and see if we're on GCC 16 by that point. If GCC 16 is coming out this year or already came out, I don't know. But yeah, wanted to make everybody aware of what we currently test in CI primarily. Deprecated package removal, I'm not going to go through the laundry list of this. It's some kind of technical minutia that most people probably don't care about if they're not using the deprecated packages. The important thing is 16.2, they're still existent. You can go get them in the history of Trilinos. They're archived elsewhere on GitHub. They're not in 17 and onwards, and they're not coming back. So this is a really refreshing ability to remove deprecated code. That doesn't always happen very effectively on a lot of projects, so I was really happy to see this go through. The important thing here is that the references to deprecated packages have not been removed from all source code files. So this, for example, I think Mulu actually has removed it, but okay, they haven't. Mulu could depend on Amesos or Amesos 2. The references to Amesos are still in the Mulu code, but there's no way to turn them on. So it's really dead code. We want to get that all cleaned up, but it's not critical to the customers. It's more of an internal maintenance thing. And that's been deferred to target Trilinos 18. Okay, FY26 plans. I've already touched on, I think, almost all of these in the course of this discussion so far. A lot of them have to do with builds we plan on adding either nightly or in continuous integration. But the first two, I don't think I mentioned that much. This is a prelude to Joe's talk at 11:30 today. We want to take a better ownership of the ability to build Trilinos with Spack. Realistically, that's a great way to reach new users. We have people that want to build it, but we have people that build other software with Spack. If Trilinos can work into that in a way that they can make use of it, we're much more likely to get to grow our existing community. So I won't talk about that a whole lot, just because I still don't know exactly what that's going to look like, other than making the package.py featureful enough to support meaningful configurations. I think I've touched on most of the rest of this. We have some internal Sandia customers, large simulation suites. 2 of them that we want to add pull request builds representing as close to their exact configuration as we can. I think one good example is one of them really wants float support turned on, but not and complex support, but not complex float. It's one of those things that doesn't break frequently, but it breaks like once a year, and then they get very, very disappointed because we have to go, and it's something that we could catch with a PR build. I think I covered everything else except for these last 2. So we do, if anybody saw, there was a good talk earlier about how to secure your GitHub Actions-based repositories. We do use CodeQL. Chris actually set that up a couple years ago for Epetra and Mulu. We expanded it out to work on the whole code, and then it went through a period of not workingness because there were some cert errors, or I think some, I don't remember exactly what it was. It was something related to the pulling certificates. Anderson got that fixed, but there are a lot of timeouts on that build. It's very expensive to do that analysis. Trilinos is very big. We need to look at if we can increase the runner timeout on that one, but doing it at pull request time, if you're not changing a lot of packages, it tends to run and complete, and we get meaningful results. I've been watching it for a couple of weeks now. We want to get that better and get that into production, ideally get that required long term. And then the last one is a bit of a 11th hour thing we added, but Kurt and I have talked about this a couple times. If you saw my previous talk, I'm not optimistic about the ability to provide a single installation of Trilinos and it work for a lot of customers. But at the same time, it's very low cost for us to provide binary distributions of Trilinos now with our CI containers. Effectively, if we just do an install in those same containers and then package the images up and send them out. So even if it doesn't work for a huge percentage of customers, it might be a great way to kind of lure new users, especially from like universities, by saying, hey, we have a container image you can just install, and we've got all packages of Trilinos build. That's one hurdle for a lot of people to clear, with all of the third-party libraries for all the I/O stuff and everything. But it might only target the Ampere 100 GPU, for example, if they're trying to do a GPU usage of it. But low cost, hopefully middling impact. So we want to finally do binary distributions, and that might grow into, if we have the infrastructure to do that, that might grow in a nice organic way. So that's all I have.
Would we be able to do in binary distributions of NVIDIA, or is that still problematic?
I don't think so. Or sorry, I don't think that is problematic. But that is exactly the reason that I've been reticent to, or hesitant to distribute our container images, is there are licensing questions about the software that's in them. I don't have the resources to go answer them, but there are other people in Sandia who would really like to see those containers go out, and they said that they would take care of the licensing investigation for us. Jonathan?
The tail end of the CMake profiling talk?
I saw the very end of it, yeah.
I mean, is that something that, I mean, I realize it requires a big bump in the CMake version.
I'm not really that worried about that these days.
It's not bad.
It's not bad.
Like, see, it's 40, but we're building that, we can build that through Spack without problems. I just don't know if it works with Trilinos right now.
Ross has tested it. I think his if I remember correctly, his response was, because he tried to do it using Spack because he can just apply it easily, right, and it'll work. His frustration was there were things that we depend upon that will not build with CMake 4. If you want to build with your stack with multiple CMakes, again, you can do that in Spack, but it requires a little bit more gymnastics to tell it, I want this one to use that CMake and this one to use this CMake. But I think he tried it manually, and it did work when he tried it, and he implored me to add an upcoming CMake build, and it just wasn't a big enough priority. And also partly I wanted to wait because part of the whole advantage of using Spack with the Spack package ecosystem is other people will fix those builds as CMake comes out, and we can wait a month and take advantage of that, or at least diminish the number that we have to go fix ourselves. It's not a pressing need right now, but yeah, we can. Whomever wants to say something first, Spack. Jeff?
Could you go into more detail of how you use containers in your CI and how you reuse stuff between different CI runs?
We don't reuse stuff between different CI runs, but we could. It's something that's, you know what, I'm gonna put an asterisk. We do, but we do it via Ccache. So we do it via direct object file caching. We mount a directory on the host. We point Ccache in there. It caches all the object files, and then like I said, we actually get like a upper 80s to low 90s hit rate.
So is that mostly for your own object files, but then you have like a Spack instance that you're also pulling for all your pen?
Oh yes, so you're right. That's now that I'm thinking about it that way, that's a great question. The containers have full Spack installations of our stacks already in them, fully archived. It's just our own stuff.
But the Spack instance itself is relatively snapshot. How often do you update that Spack instance?
As often as we need to. I think the last time we updated it was in September, so not very frequently, but we do it in response to new capability in Spack. We definitely did it in response to the compilers as dependencies because we had time and we said that's a big one. We want to make sure that's out of the way. We did upgrade it once right after that because there was a bug fix for I don't remember exactly what in the Spack engine itself, and it was like trivially easy once we were on Spack 1 because it was also only maybe a month version of the code, but as often as we need to. It's not typically a big deal. It just takes a lot of time to build the containers. They build automatically overnight. There's a bit of a process to update them in our CI pipeline, but it comes at the benefit of everything is fairly tracked now. There's like one manual step where you have to go do something on the runner nodes, and we can get rid of that long term, hopefully by going to something like Kubernetes. Jim?
So containerizing all the CI builds was a really big step, and then publishing all the containers and the workflow around that and the documentation. Have you had some feedback from non-Sandians about the ease of being issues that people are seeing in the PR builds, or is that yet to come?
A little bit. I don't want to self-aggrandize, so I'm not going to try to sell it as like, oh, it's been this amazing success externally. But I guess we're done with that anyway. But I heard via one Trilinos developer that they had some university colleagues that were very excited about the ability to do this. I did not hear the results from it. I think the results were they are very excited but disappointed that they still have to build the containers themselves, but they were able to do it. We've had, and then I heard directly, I feel like I saw a GitHub issue about it as well with one other person that said, hey, this is pretty nice, but
I wonder if we should work with like the CI working group at HPSF about they still have to build it themselves. It wouldn't have to be us, or maybe we could have these things available.
so that's really only a licensing question. Again, I didn't want to, it was one of those things I didn't want to get distracted on. If the licensing question is figured out, trivially easy to publish the images. We can push them straight to Docker Hub. We can push them to the GitHub container registry. Wherever they need to go, we'll put them out there.
And just to be clear, when you say publishing containers, do you mean images or do you mean recipes?
Right now, the recipes are all published and public. The images are upcoming, hopefully. That's what that last bullet is. That last bullet is the images plus the Trilinos install that will be in the image. So, Jeff?
So one thing I didn't appreciate due to my own ignorance is that being on GitHub changes things a lot for you guys. How would this have changed if your code just all lived, say, within the RE or whatever Sandia's equivalent was, where it wasn't in the open but a class? So you could actually see, like, say, RE add-ons and stuff like that.
We have had in the past the infrastructure, and I work on other code projects at Sandia, so it's not something we'd have to reinvent the wheel to do all the right testing on. The real hassle comes in, what do we do? There's two facets to it. How do we approve external contributions to be tested and run on the internal machines? We've largely figured out a way to do that in the past that's acceptable for our people. The bigger annoyance that is hopefully getting resolved soon not with those machines, is the ability to return the results out to the wider community, right? It's this black hole where I submit a change to Trilinos and then I get like a red check mark back or red X back, and then I have to go and email somebody on the Sandia side who theoretically has to go get the results approved and like get them back out to them. It's not a great way to do community development. So where possible for an open source, especially a foundation-based project like this one, we want to push the testing as far outside as reasonably possible. Exactly that is why we started talking about the Frank system for the MI300As, even if the hardware configuration is not the same exactly as the supercomputer that we're targeting. It's like, is the trade-off worth it to make the results public? So.
And are you able to use, or did anyone mention using Browne and Los Alamos to have a second, I don't know what the access is from the outside, but we have our own Frankenstein cluster. And I don't think we have any MI300s. That might also be an option.
I don't know that cluster specifically, but yes, Los Alamos did come up with respect to the, I think for some of the Grace work.
Okay, yeah, I know we have to do Grace nodes there too.
Yeah, it did get mentioned. No immediate plans. We can only do so much.
Yeah.
Alrighty, we probably should go ahead and move on. Why don't we go ahead and thank Sam.